Hello and welcome. This is a presentation on Docker and security that we did originally at the Cadence Group's Black Ops training seminar. We did have some technical difficulties at the beginning of this presentation, and so I'm going ahead and redoing the voiceover here at the beginning. First and foremost, I want to thank Cadence Group for putting this together. They're awesome to work with, so if you're looking for help through the compliance or security challenges, don't hesitate to reach out to them. And also, Doran Barton was amazing in helping to help get this video re-spliced together, even though we had the screens in the background stop working, and I'm greatly appreciative of him doing that. If you are interested in containers and how security and compliance comes together, this is a presentation for you. I go through and do a high-level introduction to containers in general just to lay the groundwork, and then I follow up with some of the key things that you need to understand when it comes to security and compliance. I'm Brandon. I love to do technology in general. If you want to know more about me, you can visit my blog at surfingthe.cloud, and don't hesitate to connect with me. You can see my connections here on the screen. I also, throughout this presentation, have referenced another book I've written called Activator. You can find that on Amazon, and it's about successfully getting through change in the tech industry. And without further ado, let's dive into things. There are going to be some places where I actually have some stuff you could try running if you want to follow along. If not, it's all good. This recording is going to be made available for reference later. Those of you who have used Docker, what kind of experiences have you had? Good ones, bad ones? A couple hands. Have you like it, dislike it? What are your thoughts?
I love it. I actually have it running on my laptop right now, so expedites the development process in many ways and makes it so that what rolls out to production is what you're running locally.
Yeah, expedites the process. I think a lot of people maybe have heard that it might make it more confusing. How many of you have heard of Docker but been kind of frustrated because it seems like the people who really like Docker are kind of fanatical about it maybe, and you don't understand why? Have you guys seen that or felt that maybe? I think a reason that happens is because once you get your head into it, it really is exciting because it feels like, oh, finally we're actually getting to a point with system administration or systems in general that's really exciting. And so that's why people get really excited about it. And we're going to talk through that. I actually have two kind of approaches to this presentation today. The first half of this is going to be just an introduction to Docker in general, and then we're going to get into the technology behind Docker, or behind the security side of what we're here to learn a little bit more about. Before we dive into that, I wanted to talk a little bit about change, and this is really what the Activator is about. The problem we have in tech is that the technology changes so rapidly. I don't know of any other industry where tech changes so frequently that what you know fast becomes out of date. And so when people, you spend years learning whatever tool set it is you're doing, if you're doing InfoSec or System Administrator, whatever it is, you come to love those tools because you figured out how to use them. And that process of learning how to use them, there's some blood and sweat involved in that. And then someone comes along and says, it's great, you've learned that, but everything you knew, now let's just set it aside because it doesn't matter anymore. We're replacing that technology. And that puts people into a place of fear. Docker is very much one of these disruptive technologies because everything that you know kind of changes. You have to go through this mind shift to get your head into how to do it differently. You can't treat it the way you used to do it, and so that puts people in a place of fear. And what happens is you end up getting crusades going on in the company where people almost behave like 15th century arguers, like, you know, you're arguing the scripture of what was good or what is good, and this can be a problem. And so you want to avoid that, and this is great that you guys are here because it hopefully will help get your head into kind of what the values are of Docker and containers in general. When I talk about Docker, I say Docker, I mean the general concept of containers. Containers started with FreeBSD, I think, did gels first. Solaris did zones. Linux brought it in as containers. Nowadays, when you say containers, they're largely a Linux thing. Windows did add in an extension to allow you to run containers as a Windows thing, but really by and large, they're a Linux thing. Even if you have a Mac and you're running Docker, you're actually running it in a Linux VM on Docker. To help us understand the change for what Docker is, I want to talk about how we've done system administration up to now. If you think about a factory, and this factory, let's say, is making airplanes, and you have this big giant factory floor, the way that we've done it is we go out and we draw little parking stalls all around the factory. So the whole entire thing is just a big, vast array of parking stalls. And if you're doing manual system builds, what you do is your engineers go out to every single parking stall and they start building one plane at a time by hand. And so every plane is handcrafted, and that's no good. And so we said, we need system automation. And so Salt, Ansible, Pup, these sorts of systems have kicked in Puppet to help us. But what they did is they didn't bring in the assembly line like we wanted. What they did is they just created robots that went out to every single parking stall, and they put the widget in every single plane. And so, you need a new steering wheel, you send the robot out and it hits every single one. Well, the problem with this design that we're still having a problem chasing with servers is that it breaks down when you start thinking about what's happening. If you need to build a pipeline, this is your classic assembly line. You have a dev production or dev stage production environment. You don't typically build a server, run it in test for a little while, and then after you verified it's good in test, move it to staging, verify it's good in staging, then move that server into production. That's just not how you typically do it, even with virtual machines. And it should be, because that really truly is getting closer to how we test and evaluate systems. Instead, what we do with our automation is we go out and we make a system that creates just a dev environment, but if you want to move something to stage, you actually create a new environment for stage and a new one for production, and you get that reproducibility really well. The reason this can be a problem is if people want to make changes. So if a developer needs something changed to that environment, they have to go through this process, and they might change it in dev, but maybe it wouldn't make it up into stage or prod, or if they do, they have to do it in 3 different places, and it just becomes kind of difficult. And if they do make a change to a server, and later on you send the robots out to fix it, well, now that change breaks the automation, and the robots can't do the work. And you've probably all seen this sort of thing happen, whether you're using Puppet or Chef or Ansible. And all of this just creates friction. And Docker and containers are about addressing that. And the real reason this is a problem is because we're chasing state, and state is time. And this is the heart of the issue. So if you think about a computer, you can never be real time with computing systems. This is the heart of all computing. It's a challenge. If you take a measurement from a computer of temperature, you know that at the time you took that measurement, it was accurate, but a minute later, you don't know if that measurement's right anymore. You have to go back and take a new measurement. And an hour later, you have to go back and take a new measurement. That's state. And with our change control systems or our security systems, we never know what the current state is. It's always a past state, a historical state. And so instead of chasing state with container systems, you build it ephemerally. You're basically embracing this change. And you're saying, I'm not going to try and keep up with state, because that's actually a losing game. It's a net loss. If you try and always chase state, you're going to always be behind. You're never going to know for sure if I'm good or not. And so containers say, let's just forget about it. We're going to build ephemeral systems. And what an ephemeral system is you build it once and you throw it away. You never update it. You don't patch it. And that can scare some of the InfoSec people in the room to say, don't patch. Because I believe in patching everything. And so we'll talk a little bit about this. What's happening is you just don't bring it back for repairs, because by building it ephemerally, you're saying, I'm going to make it so easy to rebuild a new system with the newest patches that the old one can just be thrown away. And that's really the key shift, is you're not going back and you're not scanning containers necessarily with like agents that run all this stuff, because you just create a new image, you sign it, and you push it out. And we'll get into the details of the images and things. What this does is it's brought in this concept of low-cost building blocks. And if you think about what happened to the shipping industry with containers when containers came in. So there's 2 reasons we call this containers. One of them is they're containing the process space, and the other one is it's kind of parallelizing what's happened in the shipping industry. Before the shipping containers hit, when they wanted to ship stuff around, you would take crates, and there was all this manpower involved in loading and unloading trains and all these different boxes and freight systems, and it was a highly complex system. And then they said, wait, if we just have a box and you put whatever you want in the box, and then we'll just move boxes around, all of a sudden shipping got really easy when they just started moving boxes of one size. And that's really what's happening with Docker, is you're saying, I don't care what's inside the box as much as I care about moving and managing moving the box around and how the box interacts with other systems. So instead, in the past, you would always build your servers to match the shape of the application. And so the servers would have all this automation or whatever to match the shape of that application. With Docker, you're flipping that over and you're saying, you know what? It fits inside that container, and I'm just managing the container. I'm managing network access to the container, and I'm just managing it as a general universal piece. And that's what makes it powerful. So as we go from containers, this movement in DevOps, how many of you guys are looking into DevOps or continuous delivery? Or let's start with DevOps. DevOps first. Have you heard that? Interested in that? What about continuous delivery? Do you guys know if you guys do that in a development system? How frequently are you guys releasing? Let's go back. How many of you guys know that your software, your changes are released at least once every 6 months? Is that a good push? Less than 6 months? Okay. How about once every month? Once every day? See, that's continuous delivery. If you're pushing more frequently, I could have a whole talk on continuous delivery, so I won't go there very long, but containers and DevOps go hand in hand. And the reason that we have DevOps is to address this problem. If you've ever heard of this or seen this, what happens is people like to, because of that change that happens so frequently, people like to build up barriers and say, this is just the silo I care about. And so we've created an environment where the developers are so detached from production oftentimes that they don't even know what's going on. They just push code over the wall, and it's really frustrating to the InfoSec and the operations teams because of this. And so DevOps is about everybody owning production, and containers help us with this. But the way that we do automation up to now is no longer the way that we do automation in containers. If you feel the urge to take your historical automation systems like Salt, Puppet, Ansible, and Chef and bring them into containers, stop yourself, because you're probably going to make your life more complex. Along with DevOps has come DevSecOps, and that's a little bit about what we're here for today. In DevSecOps, everybody owns security. That's the concept. Same as everybody owns production. You want to share that ownership around. The problem is then you end up with this problem. And most people like to think of security guys, they think of it like, I just hired a network security person. That's kind of like hiring a guard at the bank, right? They're taking care of security for me. I don't have to worry about it. So with DevSecOps, the idea is that everybody's actually involved in security, from the developer all the way through your operations team to whatever. And your InfoSec people become more of a guiding hand in that process. So security is also changing, especially with a lot of the visibility to some of these breaches lately with, not Executech, who was it that, Equifax, right. One of the first things you're going to run into when you start really getting into containers is everybody says containers make life simpler, and then you start using it and you go, wow, this is really complex. Containers can feel that way. One of the ways of making sure that you avoid that complexity is you actually want to follow some idiomatic patterns. If you go out and Google, you can go to my blog as well on Surfing the Cloud, but if you go out and Google idiomatic container patterns, it'll come up with my blog post. I've gone through, there's some things called the 12-factor application, as well as just personal experiences and other people's ideas, and I've consolidated these into idiomatic container patterns. And what these are is, an idiomatic pattern is something that is the easy way or the simple way, because you can do in tech, you can do things any way you want. Sometimes you will choose a path that is more difficult. And with the idiomatic patterns, the idea is if you follow these paths, your life is going to be easier in containers. One of the key things that I've usually seen people do is they'll try and make containers be virtual machines. Containers are not virtual machines, and we'll get into that a little bit here. I don't have time to go through all of the patterns. I urge you to go out and take a look at these. At a high level, there are two patterns that kind of underlay most of these, I should say, not patterns, but two principles that underlay most of the patterns. One of them is you never update, like I've been talking, they're ephemeral systems. And the other one is you have one function per container. Who of you, I know, Tyler, you've seen these idiomatic patterns. Has anybody else seen these idiomatic patterns or heard of the 12-factor app before? The idea of one function per container is really at the heart of what makes containers different. If you think about an operating system, when your operating system boots, it brings up a kernel. The kernel brings up an initialization system, a service process management system that then brings up all of these peripheral services like your networking stacks and your system logging and your inter-process communication and maybe your SSH, or all these other things are running, and your storage and whatever has to happen is running, and then eventually your service runs. And so if you have a Ruby service, it will eventually show up after all of these other things happen. In a container ecosystem, the key difference is that containers are not emulated virtual machines. They are just processes in one kernel. So you have one kernel that's running, one Linux kernel. And then when you containerize something, it's basically taking and partitioning and saying this process that's running alongside all these other processes, this one process cannot see anything else. All it can see is these resources. And so the startup becomes a lot quicker. So you've already got a running operating system at this point. You then boot a virtual machine. It runs a BIOS. The BIOS runs a bootloader. The bootloader runs an operating system loader. The OS loader then runs the kernel. We're getting closer. The kernel then runs your startup systemd, whatever init system. That then starts running all your peripheral processes, your networking, your storage, whatever other things we talked about. And so you're doing this twice now in a virtual machine. Your host OS has already done this, and now you're doing it again in the VM. You have a separate kernel, and this is why you have a lot of overhead. In a container, with it just being a process in the same kernel, all of that's already there. It's already running at the host. What happens when you start your container is it goes out and it takes, and really in a split moment of time, it creates a little isolated containerized space of networking and storage and other dependencies that, like other drivers or whatever you might want to bring into it. And then it just runs one process. And so that's the one function per container concept. And I'll get to it later, but oftentimes the most often question people have with containers is, how do I log into the container? You don't, because to log into a server, you have this whole ecosystem of processes, including a SSH service, and you log into SSH on the server. Well, there's no SSH running in this process space. If your process is Ruby stack, there's no SSH service there to even log into. Does that make sense? And we'll do this with an example maybe. If you were to run this command, and just trust me on this, this command is telling Docker, go ahead and take this image. The image is Alpine. I don't know if the font's too small or not. Take this image and run this image. Now an image, I'll go through in a little bit of detail in a second, but an image is basically a grouping of libraries and programs that run in Linux. And then it says run this program. In this case, I'm saying run bin sh inside the image. Now there'll be a default. I'm overriding the default by saying bin sh. So I'm saying give me a shell in a container. That's what I'm saying here. Now, if you run this command right now, you'll probably see a little bit more than what happened right there. But right here, I just got a prompt. What you'll see if you don't have Alpine, and this was my mistake from the example, I have Alpine cached on mine, so it just went boop and popped right into it. If you don't have it cached, then it will say pulling Alpine down, and so you'll see a couple more lines there. But all that happened is I've now got a shell inside of a container. And to show you how this works, if you want to try this, you type sleep, and this runs another command inside the shell. And I'm back to the shell. And if I do a process list, that's all of the processes running in the container. That's it. And so you can see process number 1, bin sh, the command I told it to run. Process number 7 was sleep, because there's a couple of processes that have probably run to get sh going. And then you see the process that I ran, the ps list. And so those are the only 3 processes running inside the container. If I go outside the host that this is running on, and I type a ps-eaf, I'm probably going to see about 800 processes, because of all that ecosystem of other stuff. But along with those, if I grep for sleep 1138, I'm going to see my process from the host level. That's the big point to recognize, is that all those processes are in the same scheduler as your host. Any questions on that before I jump into images? I think that's a big hurdle for people to get over, is to recognize it's not virtualization. I was at another seminar and someone was saying, well, I want to replace, I know containers run much more efficiently. And so I want to have my students use this to, instead of using virtual machines for security testing of viruses and stuff, I want to do it inside of a container because that'll be faster. And you have to ask yourself, well, if it's just a process, which process am I running in that container? When I run a graphics console for virtualization, a VM, you're running a whole bunch of processes to make that console work. You have to have mapped your graphics device into the container, which doesn't happen by default. And if you map your graphics device into the container, that means that your base host doesn't have the graphics device anymore. So you run into a lot of problems with that because of what's happening. Images are different from virtual machines because virtual machine, you're doing a block level device that has a drive on it, and you're loading a file system and doing all this other stuff. With images, the really simple way of thinking about it is that images are kind of like a tarball or a zip file, where you've taken some basic OS, the bare bones of a base OS, and you just zipped them up. And you said, that's the start of my image, and then you just create layers on it. So think of it like if you were to take a stack of paper, and they're all semi-transparent, and you start with one piece on the bottom, that's your base image. And then as you write things, that will go to one layer on top of it, and you can read through down to the base image, but if you read something you've already written, it will come off that top layer. And you keep creating layer after layer, until you have this image that's a set of all these changes you want to make for your Docker image. So to visualize this, this is what a Docker file looks like. I start by saying I'm starting from CentOS 7. And there is a base image repository out there from the CentOS group that is the basic CentOS 7 image, and it's very bare bones. Alpine is the other example I used as a base image. I'm a fan of Alpine because the size of that base image is 5 megabytes, so it's tiny. really, really tiny. I think the base CentOS image, I haven't looked at it lately, but it's varied around 150 to 200 meg. So that you can see, and same with Ubuntu and Debian, they're all going to be around that 150, 200 meg range. So you start with the from, and then you go ahead and run a command. So here I do a run yum, that becomes my second layer. Then the next command becomes another layer. After the image build is done, Docker will clean it up. So I'm skipping the work directory. Any image that doesn't make a change, it deletes from the set until you have your final set of changes that are part of that image. And that then gets stored off to a registry. And every image is signed saying, here is the signature of what's in that and contained in that. And that will become important for what we're doing later. So that registry is now a central repository of all of these changes we've made to make our system. And then when we run our process, it takes and brings together networking. It brings together the container processes themselves, that one function per container, as well as the image. And all of that together is the container. So the container is only the running state. And this is also kind of point number 2 that's really important to get your head into. With virtual machines, it's a virtual machine when it's offline and stored on disk, and it's a virtual machine when it's powered up and running, and off and on and off and on. It's the same virtual machine over and over and over. A container is only a container when it's running. When you've turned it off, it's now just an image on disk that's a container image that has the potential to become a container, but it can become 10 different containers or all the same. And I know I flew through Docker at a high level, so before I move on to security, are there any questions on just kind of Docker at a high level? Do you think you're getting your head into that a little more? Did that help, that explanation of Docker containerizing and separation and ephemeral states? I'm seeing nodded heads. Yeah.
So at the host, at the host level, you can see all the processes, including your individual container processes, right?
Mm-hmm.
So I'm assuming you're going to have to secure the host.
You do need to secure the host. So, and I'll get into the securing. Yeah. Yep.
Okay. I just want to make sure. It sounded like they couldn't see each other, but the host can see everything still.
The host can see everything. That's a good distinction because the host can see everything. If you have access to a host that's running Docker, you have access to every single container on that host. You just do. If you have access to a container for some reason, but not the host, you're still contained to that space that container's in. But access to the host is access to all. And so that's really a control point for security. Here's the points we're going to hit. We're going to talk about scanning. This is a big thing for security people is how do I scan containers? We're going to talk about accessing, how do I log in? We're going to talk through how do I deal with logs as well as config management. And I didn't have the bullet on here, but there's one more, is scoping and isolation. So when you scan, take a step back and ask yourself, why am I scanning? If I'm doing scanning of a host, you have regulations that have driven it, but really you scan for 3 primary reasons, right? Tell me if I'm missing anything. I'd love to get this updated. But we're scanning to understand, do I have anything vulnerable inside my image? Now, I'm not saying malicious software. I'm just saying I might have a version of a library that has a vulnerability that I don't know about. Like, I need to know about it so I can get it updated if I can. So vulnerability is part of that. Antivirus is, do I have any malicious software that's on that image that I don't know about? And I'm using antivirus in the general term here. It seems to be the common thing, right? As well as file integrity is, have my files on this image changed when I didn't expect it? Like that might be an indicator that someone is maybe breaking into that system. And when you break into a system, they're going to try and change files on disk so that when your program restarts or reruns, then it will run the bad program instead of the good one. So that's why the file integrity monitoring. What do you guys think? Does this hit kind of the high level things we're looking for with scanning? And to your point, hosts and containers are different. So everything you're doing for security, you still should do at the host level. Whatever compliance requirements you have, still do it at the host level. But when it comes to the containers, you need to kind of dial it back a little bit because containers are giving us a lot of these same protections just in different ways. So we'll walk through that. File vulnerability scanning. Well, when you do that image build, you have the opportunity to scan it right then and see if it has any vulnerable components. And the cool thing about the image that I didn't mention was if you have that image, and I was talking about the assembly line and the pipeline before, you have this image now that you've made, and you can take that same image and you can run that one image in development, and then without making any changes to the image, you can take and run the same image in test and the same image in stage and the same image in prod, and now you have this opportunity to truly test everything about a change, including all the dependencies and all the libraries, because you're coming from the same origin image that's been signed and isn't altered because it's coming out of that registry, so on and so forth. So now if you scan it at creation time, you know that it has vulnerabilities or not. And when you make an update, it'll actually be a different signature and a different image will be the net result. And so you'll run from a different starting point. Docker itself even pins to those signed images. So if you do a deployment, it will go out and find that signature hash, and that will only run that one. So even if you push new updates, until you go in and say, no, change and run this newer version of the image, it won't. And so you have to actively tell it to switch. So you can do vulnerability scanning at runtime. If you want to use Docker Hub, that's a registry that's available from Docker. They have a scanning service that will go through and it will tell you on each layer the different vulnerabilities it's found. And here's an example of running Alpine. And I did this back when there were some vulnerabilities. It's been updated, so this isn't the case anymore. But it'll show you, hey, you've got, through the bin utilities library, you're bringing in GNU bin utils. And what's going on here is you have to understand why your components are in the system. So you could scan any Linux system and probably find the same vulnerability. The reason this may or may not show up in the Alpine ones comes down to the libraries that are going on. There was a dependency that brought in the GNU libc bin utils. Those don't necessarily need to be there. And so you ask yourselves, when you're creating these images, what's the smallest amount of binary data I can put in there so that you have the least amount of exposure? I think a good example of this is when I started at a certain place, the image we were using was based on a Debian OS. And when I started doing the vulnerability scanning, we were getting 600-700 hits on vulnerabilities. I switched it over to Alpine and it went down to about 10. And that's just talking about reducing risk at that point. And you'll have host servers out there that still have those 600 vulnerabilities and they're passing all the compliance requirements. Because these kind of may not apply to your application. This one specifically, you have to have a specially crafted ELF binary in order to violate this vulnerability, and so it's just something that's not likely to happen. So this is one where you can say, I see it, I recognize it, and I'm moving on. Antivirus, same thing. You can scan for viruses inside that image at runtime, or at build time, I mean, not runtime. File integrity monitoring. Have my files changed when I didn't expect it? This gets interesting with containers because containers are still, you can change what's inside of a container, but if you remember, they run ephemerally. So every time I launch a container, it goes back to that signed image, and I get to throw away what I had, and I start over from a nice, clean source. And you look at the question, you ask yourself, why do I have file integrity monitoring? Well, it's so that I'm not running compromised binaries. Well, if you're always using signed binaries, and you don't run anything but from a signed binary, it actually helps meet that requirement right out the gate. And then you can just tell yourself, I'm just going to restart. So if you have a regulation that says you need to do antivirus or file integrity scanning every interval, you just make sure that your container starts from a known signed image at a certain interval, and you still are meeting that requirement. For example, in PCI, how many of you guys are dealing with PCI? Where I'm working right now at Divi, we just finished up with Cadence, and so we've gone through the PCI things, and we've mapped these things out as well. There. So in PCI, one of the requirements that I picked here was protect all systems against malware and regularly update antivirus. And the guidance is there, I think, are that you run antivirus once a week, if I recall. Casey, was it once? Or FIM, periodically. Yeah. And so if we're starting from a signed image, we're okay because we've already done our vulnerability scanning. We're running ephemerally from a signed image, and so that's okay. And so we just say we're going to restart it every day from a known signed source. That's less than the interval we have to scan on. And so that still meets the requirements we have in place.
So quick question on that. You still have, so your container is an image. You have to deploy that, scan it, and then repackage it, right? If it finds anything. When you create the image, you store the image into a registry. And like this service I showed you here from Docker, it will just scan it offline for you, out of band, or in line, however you want to do it. You can wait for it to finish up. But when you push something into these registries, they're in there and they're signed and they're done. And then you pull them down onto a different host or a whole swarm of hosts. And so it's part of your delivery process. But once you've scanned it once at the build time, you don't need to scan it anymore after that. I don't know if that answered your question or not. Okay. Yeah.
Is that service from Docker free?
for now. It's part of their hub. Their hub charges for storage. Unless you're publishing the container image for free, they charge you for storage. And if you have a paid service, it's like $12 a month for like 5 containers. It's not much. Then they're giving it to you for free right now. You just have to go enable it.
Yeah. Okay.
But there are other services. If you get Docker Data Center, it comes with the same thing. It's built in with Docker Data Center. Any questions on scanning before I jump on to the next topic? Yeah.
So one of the concerns I have about vulnerability scanning is that I'll have a container that has done this one function and it hasn't had to change for a long time, and the libraries that are on it, though were vulnerability free when pushed, are no longer vulnerability free. How do I discover those?
I'm going to come around to that later on in the presentation, but it is a concern. You should be rebuilding those images and redeploying them on a regular cadence. That's the long and short. But I'll come around to that. That's going to be towards the end under config management. So logs. At a high level, when you boot up your server, and we went through that whole process, or virtual machine, your kernel is just a process. And then it has a scheduler that runs other processes to manage all the other systems on your host. The output of the kernel is your console. And what you're doing with a container is you're saying that process, the output of that process, the standard out, that is my logging. This is part of the 12-factor idiomatic patterns of container, is that all of your logs go to standard out. You don't log inside the container. You don't have a logging syslog subsystem. The output of the container is the log. That's the idiomatic way of doing it. And if you do it that way, it becomes really easy because you don't have any log management. Kubernetes or Docker or whatever it is you're running takes care of all that log management for you. If you do it inside the container, then you do have a little bit of friction there because it's going to be a little challenging to manage. Logs, though, on the host are also important. And before I actually get to that question, the next bullet here. You still need to pull all the logs off your host just like you would normally, because that's usually where your controls are going to be for the different compliance and InfoSec. Like who can log into that server, when did they log in, how many failures have there been. All of that is on the host level, not inside the container. And so as long as you're pulling your host logs, that's the number one thing. Your containers then are outputting their logs, and depending on what your container is doing, there may or may not be a requirement for containers to have the logs, but you should just centralize all your logs that way. So here, if you run a web service like Ruby, the output of that web service is its logs, and then that gets centralized and brought together. I have a whole section in the practical Docker book on dealing with logs, because if you don't follow the idiomatic container patterns, it can be challenging. It's more of a developer challenge than anything, not an InfoSec challenge, because as far as InfoSec is concerned, as long as you're pulling the host level stuff, you're probably getting most of what you need. The containers, I mean, if your InfoSec requirements care about the output of Apache, then maybe you also need to care about what those containers are outputting. But generally speaking, that's not in the scope. It just depends on where you're at. If you're doing WAF type stuff, maybe it would. So that's where you have to ask yourself, what are you required to collect? And understand your compliance requirements. They can vary depending on the regulation and what you're looking at. Do your audit and access at the host level. So here's one of the big questions people ask, is how do I log into a container? And so you have to go back to the idiomatic pattern of saying I have one process per container. And if someone says, I just want to SSH into the container, then you have to say, well, is the container running an SSH service? And if the container is not running an SSH service, you're not going to SSH into the container. There's no service to SSH into. What about Telnet? Well, there's no Telnet service. And whatever it is, right? You have to have that service running in order to connect to it. And if it's not running, like if you SSH to a server that's running Docker and it has all these containers on it, there's probably an SSH service running, and that's running at the host level, not inside the containers. And so you're going to SSH into the host, not into the containers, right? This is something, as you're getting into Docker, you're probably going to have to go back to this like 3 or 4 times before your head really wraps around it. It is a little bit of that mind shift, that change. I am going to show you an example though. If you want to get inside a container and get a shell inside of a container, you can do it using a debug capability of Docker. So this is another one you can play along with if you want. At my host, in this example, I have a container that's running the Squid service. So I went ahead and I did a Docker PS, which lists all the containers on a host, and I just searched for squid. I found my squid service running there, and then I went ahead and I ran Docker exec. Exec says, go ahead and add a process to that container, and then I say, this is the process I want you to add. I want you to run bin sh inside the container, and then the -it is saying, give me an interactive TTY. So now I'm in the container, and my terminal input is in that container, just like it was before in that previous example. This is a running container that's already there. If I do a PS, I can see I've got one squid process running, and then I've got my shell. And so now I'm inside that container. If I do an IF config, I'm going to see a list of interfaces that are network interfaces that have nothing to do with my host. They're just for that container. Docker does network isolation and all that. I'll hit the isolation on networking a little bit later. Any questions on this example on how to grab a shell? Can someone tell me something that was missing that like might feel uncomfortable from what I just did here? If you were logging into a server, what would also normally happen? Authentication. There was no authentication here. Having access to the host is authentication to all the containers because you can just do this on any container. So all of your controls need to be around the host level. So what about accounts inside the container? If authentication is done at the host level, are the accounts inside the container different? Does anybody know? Than the accounts outside the container? There is a separate password file. And because I'm running, like I could run CentOS as my base host OS. And in the container I run Alpine. And Alpine is, that disk image is completely isolated. It's chrooted. And so it has to have a library that says authentication and users, like get password entry. Well, that library is going to turn around and read etc password file, and it's going to read the etc password file from the container's image, not from the host. And so it depends on what's in the etc password file. And if I just actually cat the default password file inside of Alpine, that's what I get. There's not a lot of accounts there. It's just kind of some skeleton accounts that Unix expects to exist to make it work. But if you think about it, there's really no need for anything else. Now, you could add other accounts to this set of accounts. They're just in the container. If you think about one of the common requirements or rules of running processes in Unix is you want to not run anything as root, right? That's like faux pas 101. If you run services as root, then it's a challenge and a mistake. Everything in Docker inside this contained space is running as root, which can be a little frightening when you first think about it because, well, it's running as root, but it's running as root inside the container. And all that it can do is talk to itself. And so it's kind of like saying, if I have this service process, let's call it Squid, as my service process user, and Squid can only write to Squid's home files in the home directory and nothing else. That's acceptable and that's good practice. Now I say I have a container and I've put inside the container image only things that this container needs to change. And not only can it not talk to anything else, it can't even see any other files on that host. All it can see is the stuff it needs to change. At that point in time, there's no reason to separate out the users anymore because the only thing in that container is what it needs. Yeah?
Okay, so I've got kind of a question then. Suppose I'm just theoretically, I don't know, running a website, right, inside of a Docker container. And I'm wanting to perhaps store some files. Maybe somebody's trying to upload something to my website.
Right.
I'm assuming maybe within the container there's a way it's going to punch a hole out to the host to store stuff. Because I don't want to, you know, when I update my website, I don't want to lose
Right.
all those files.
This gets touches a little bit on the stateful side of containers. There is a volume mount you can do. And you do need to scan. I'd actually blown past that point. I remember seeing it now. On scanning, you have the ability to do external volume mounts into a container. You should still scan those external mounts for viruses. You should treat them the same as you would any other volume if you bring them into the container. Generally, I would suggest you do them as a network volume, not a host volume. Because if you do a host volume and you got a cluster of 10 servers or 10 hosts, which one do you put that volume on of those 10? And if you're like, well, all 10, now you have to have automation managing, delivering your content, all 10 services, like it becomes a mess of friction, right? If you do a network volume and you just import that network volume into your container, then you can read that and that becomes easier. You're kind of moving away from the idiomatic patterns of containers, though, when you do that sort of thing. And we can take it offline, but there is a part of the pattern is idiomatic, or part of the idiomatic pattern is that your data stores should be offline, meaning outside of the container. They should be, like if it's a database or something else, you don't run them inside the container because you don't have any state inside that container. And so if it's a database or a file service or whatever it is, that's where you write it to, is that outside container data source. And then you can put your controls around that you need for virus scanning or whatever else.
So I've always seen that it's really bad practice to run as root in the container.
I don't think it really matters. That's just my opinion. Because once you're inside the container, you can switch it out of root. It just creates a little more work, and I don't know that it really buys you a lot. Because you're in the container at that point, so the idea of running as a non-root user is to isolate and contain that process's damage capacity so that it can't write to system files and stuff like that. And the reason you don't want to write to system files is because you're rerunning those same libraries. And so you think about the classic break-in, you go change a Windows DLL, and then later on when they reboot the machine or whatever, like it runs you to the compromised DLL, well, you're never rerunning. You're always starting from a fresh image. So even if that host gets compromised, you just wipe it and you start from a new image that's signed and known good. The value of running in a separate process is the risk domain is greatly reduced. I mean, there is still a fractional risk domain that you can improve by switching processes. And because it's been good practice for so long, you'll have some process like Squid, they just refuse to run as root. They must switch users. And so you put a Squid entry in the password file, then it switches to Squid and it's happy, even though not much is gained by doing that. Yeah.
So I'm assuming that what you're saying applies if you're frequently redeploying your
Right.
images, right? I mean, if you're running it for a month at a time, then all kind of stuff could happen.
Right, but I wouldn't do that.
Right, and that's what I'm trying to say, is that that's
Yeah.
important.
In fact, I've injected or inserted a feature request into the Docker community to create a lifecycle as part of Docker Swarm where you can go and say, this container cannot live for more than 3 hours. And so the scheduler in Docker will just recycle. Every 3 hours, it just pops one container and recycles it. And so you have kind of this enforced refreshing going on. And then as long as you're updating your images on a regular cadence, you're always going to be starting from good, current, signed, patched type sources.
Right, but even if you happen to be running a vulnerable one, you know that the compromise is going to go away in 3 hours. Right?
Yeah, so if someone hacks it, it will happen. Someone compromises that one container image, that will go away in 3 hours. And you'd have to ask themselves, let's say that they change the binary for Squid. They figure out a way to break Squid, and they change the binary in that image for Squid. And then the container gets, it's never going to rerun the Squid process. It's already running. It's already resident in memory, so they haven't changed it on disk. And then you recycle the container, and it starts from a fresh image, and so their attempt to compromise it is lost. So there's a lot of indirect value you get through these sorts of things. I think the key takeaway on the access and logging to the container is that access inside of a container doesn't imply access to the host. There is not a correlation between those two. Most containers don't really do logins in a container service unless they're, like Git is one I can think of. If you're running Git inside of a container, then it might do an SSH, but there's this contained SSH is a special one. So generally speaking, even with the Git one, you're not going to get access to the host by the container's access. Configuration management. This is a big deal with containers. You want to use Salt, Puppet, Chef, all these tools around config management, making sure everything's current, you don't have vulnerable libraries, these sorts of things. Instead, all of that pivots to managing your images. Number one thing is that most people go out to Docker Hub, which we've been talking about, and they say, hey, this guy's already got the application I need installed in a container. I'm just going to pull his image down because he's already done all the work to Dockerize it. Caution, right? Danger, Will Robinson. You have no idea what he's put into that image. You're just trusting he's doing it right. A lot of times, these people will publish their Docker files, and so all you got to do is take their Docker file, and then you just rerun it yourself. And now you build your own image, and you can store it in your own private repository. Now you have a trust that it's running right because it comes from a known, trusted base. Whether it's, Python or Docker, or Python or Ruby or whatever. Yeah.
I find that up on the Docker Hub, it's good to read what they've done, but a lot of times they're not always following best practices.
Right.
and things like that. It's best to know what you're putting into your image and go layer by layer and rebuild it if it
Right.
makes sure that you know what's in there.
Exactly. And then you can also tweak it and pull out things that you don't need for your use. But it's cool to see all these, their kind of recipes in these Docker files that people have published because it makes your life easier. So don't just run any container from Docker Hub. Build your own images. If you're in a full MLS, and I'll talk about this a little bit with isolation environment, you can't use Docker to separate MLS. Does anybody have any really hard multi-level security compliance requirements? Like if you're building I don't think anybody does. That's a really rare case. I don't see the MLS environments using this as isolation of containers. Like, I mean, we didn't even do it with VMware. You can't do that. And so when you go out, I've seen arguments online saying, don't use Docker to separate and isolate. And it's like, well, there's no real, I mean, fundamentally, it's actually probably better to do it with Docker even than not, I guess. I don't know. We'll get to that with isolation. The second thing is delivery of configurations. The first step that people want to do is they want to say, I'm going to put my config files into the container. And then it will just go out with everything. But that's dangerous. Don't do that. That's a number one no-no. And then you say, well, how do I get my configurations at runtime? Because that's really what you want to be doing, is you want to deliver it at runtime. The usual go-to is they put it in environment variables, but environment variables are dangerous. Don't do that. That's my recommendation. And then they say, well, what should I do? And frankly, the industry is still trying to figure this one out a little bit. I've written a tool called Reflex. Reflex does row-level, policy-driven security compliance delivery of secrets. And so it can say this secret. So there is another tool that a lot of people use called Vault-D, which does encrypted secrets. But if you have access to a lot of these things, you kind of have access to everything. And what Reflex will do is give you row-level access so you can meet their compliance requirement that says, I need to get access to this crypto key for this set of servers, but I don't want my admins to have access to it unless two of the admins come together at the same time and they both type in a password. You can do that with Reflex. You can't do that with Vault. You can't do that with any of these others. And then the other thing here is don't run agents inside the container. I met with some of the people from Salt off and on because they're in the same complex I'm at. And we've talked through the challenge these config management systems have. And the usual go-to is they say, well, let's just run the Salt minion inside the container. No, don't do that. Now you've missed the ephemeral state. Like, you don't ever update a container. So the only reason you would need a minion running inside the container is if you want to make updates to it. And you don't want to make updates to it. It is fair, and what a lot of these tools end up doing, Reflex does the same thing, is they will do one change when you start the container. So if you start a container running Reflex, you actually run Reflex launch, and then it will go and change the bits of the container to match the environment you're running in. So if it's production, it goes ahead and makes it configured just for production, and then it runs your process. And then it's out of the picture, unless you want. It'll actually go back and delete files if you want and whatever. It can even, my favorite view of this, and I think we'll get it into Salt too, is it will take all of your configurations like as a JSON file and we'll just write them to standard in of the process. So nothing ever even hits disk. If your application can support that, it just reads its config from standard in and you don't even have to worry about secrets ever touching disk at all. So with all of this, we end up having the assembly line. This is why people get so excited about Docker, is the same reason of how revolutionary the assembly line was for factories, is you now have the ability to assembly line stuff. You can take that same image, you can run it down the assembly line all the way out to production, and then if it breaks, you just create a new one and run it down the assembly line, and all of a sudden, that's the flow. That's why things become easier. So to the point of the questions, we've talked on this a little bit with deploying and building and patching. So I said, don't ever patch containers. You can't update them. What you do is you have to rebuild them on a regular basis. You have to bring them into your own repositories. You have to take your own Docker files. But Docker has a really cool functionality where all those layers we talked about, Docker will speed up your build process by caching them for you. This is really great if you want fast builds, and really bad if you want to get patches, because it's like, oh, you did this 2 months ago. I don't need to download it again. You've already run the patches. And so if you don't really try hard to break the cache, you're actually going to still think you're getting updates and you're not. What you have to do to make this right is the simple way of doing this, and this is why actually the Docker community resisted bringing in build arguments for this very purpose, is they make the build less stateful. You actually are more stateful. What you do is at the bottom of your Docker file, so all the other caching can kick in, you add a build argument. And arg basically says, this is an environment variable that will come in during the build process, but not during the runtime. And I usually use build version. And you can set it as a date. You can set it as a number, whatever it is, as long as it changes. When Docker gets to this point in the file, it will stop its caching, and then everything after that is run, no matter what, because you just broke the cache on purpose. And so the second line here, you can see I've added echo build version, and then run upgrade again. So now my container, all my software, maybe my software hasn't changed for 3 weeks, but if I run this from a scheduled job every day or every week, it will always be getting patches for the host every single time it runs. And you just run it. Here's an example of how to run that. Any question on images before I jump into isolation? Or not images, whatever we were just talking about. Config management. Yeah.
I understand. What you're suggesting is to do an update at the very end of your build.
Mm-hmm.
And so that kind of is slightly different from the model that you mentioned previously, where you're doing it, well, I guess it's still at the build level.
It's happening at build time. You just redo the builds on a regular weekly basis, on a regular cadence.
Okay, that makes sense. I was thinking about runtime.
And see, you have to deploy it too, though. So this assembly line still has to kick in. And so if you have a dev, stage, prod assembly line, you don't make a build and then just have it appear in production. You still would have your pipeline kick in. This is an area, these pipelining concept, this is another thing I do with Reflex that I don't see Kubernetes and Docker Swarm dealing with. They all kind of say, we run containers and it's up to you to figure out your pipelines. And that's where I've also inserted some pieces with Reflex where it takes care of the pipeline concepts for you, and it knows what's in which stage of the pipeline, and it has scripts to track your images and your build numbers and all of that for you. So does that answer your question?
Yeah, yes, thanks.
Anything else on building and patching, updating? Does that make sense not to update the container? The way of updating the container is you start at the beginning of the assembly line and run a new one down the assembly line. That's a pretty big change from virtual machines, right? I mean, virtual machines, you're doing totally different stuff. Getting your head into that one thing will make all the difference in helping this be less difficult. The last topic, and I know that to be considerate of time, some people got a jet here soon. I'll stick around and answer questions afterwards. This is a quick one, isolation and scope. You got to understand the scope of what's going on, what your requirements are. Like with PCI, the only thing that matters is credit cards and CVVs and whatever it is. Like, find out what that scope is, reduce that as small as you can, and then know where it's going to be in your environment, and just keep that footprint small to keep your requirements and your impact to everything else as small as you can. And then if you need to separate, you can separate inside of Docker, inside of Kubernetes. You can do policies that will say this image only runs on these hosts. You can do all of that. So you can do it inside of Docker, or if you want, you can separate it externally and say I have different accounts. I mean, it depends on your requirements. Ease of use, I actually ended up creating a separate accounts in Amazon for the way I did it, just for simplicity's sake. It actually makes it a lot easier to get the compliance finished up because you don't have this highly complex environment. Now you just have this one simple environment to worry about. But you can implement that. I think understanding your scope and isolating it, you can do any number of things. I was looking at Calico earlier this week. They are a networking stack that does policy-driven, software-defined networking for containers. So you can do your isolation of your networking with policies that have logic around how they work, and it's very efficient. And so you can do that isolation. In fact, I would say running inside a container in Docker or Kubernetes or whatever is far better than virtual machines because you actually get micro DMZs around every single process. So you can go through and say this process can only talk to itself, and other processes can only talk in on this port that I published and nothing else. And so if you're running, maybe the process, for whatever reason, fires up 10 different ports for inter-process communication. That will run over an encrypted interconnect if you want, but nothing else can talk to those ports because they're firewalled so that only the process can, regardless of where they're at in the cluster. So you get some really cool security power just from using them. So wrapping it up, getting your head into this paradigm I've talked about is a big deal. Once you get your head through that paradigm and playing with it, it almost takes just doing it a few times. It gives us infrastructure as a code, and this is where the power really comes in for compliance, because Now, all of the configurations of how that server's built and that creation of that system gets stored into a code repository, and you can do all your controls at the code repository level, just like you do with codes. You can have two-person reviews of changes. You can have whatever controls you need, and that gives you that infrastructure as a service and the continuous delivery and all that sort of thing. That's it. Well, thanks everybody for coming. If we have any questions, feel free to come talk to me. If you guys are interested, if anybody's interested in being a reviewer for the book, I've thrown some of those out. Come at least give me your name. And Reflex Engine is listed here. I've got this new book coming out, Practical Docker. And anybody who also deals with, so my company that I'm working with right now, Divvy, we do expense management better. We've replaced the way that all of this works. So instead of having to go ask forgiveness and turn in expense reports, you're actually given a credit card that has micro-sliced budgets, and you get ahead of the transaction, and it's all taken care of for you. If you're interested in that, you can go to getdivvy.com, and it's just a much simpler and easier to use service. It's been pretty good about selling itself. So thank you for coming out, and I appreciate everybody taking the time, and Cadence for putting this together, and Executech for hosting.